Hey everyone. Lately there's been some talk online about the difference between imperative programming and declarative programming. And, it's kind of a difficult subject to really nail down. I don't know why that is, but it seems like whenever I try to define it, I sometimes create definitions that bring in more stuff than I wanted or exclude things that I didn't want to be excluded from either side of the imperative or declarative debate. Actually, I shouldn't even say debate. There's really not much here that's argued, but I do see a lot of confusion in the things that people say about imperative and declarative programming. And so I just thought it might be cool to give a couple of examples of imperative style and then declarative style that does the same thing. So let's just start with an example here. So I'm working in Python, and let's say I want to write a small function that takes as input some kind of date string like that. So 4 digits of year, followed by a hyphen, followed by 2 digits of month with a 0 prefix for single digit months, followed by a hyphen, followed by a, leading 0, 2 digit day. Okay. So let's call this parse month. And let's just make an imperative version first. And it just takes in an argument called date string. So there's a few different ways we could do this. I'm just going to do it the long way, where basically I'm going to dig through the string character by character, looking for that first hyphen, storing off the position of the hyphen in a variable, and then looking for the next hyphen, storing off that position, and then extracting the substring between the two hyphens and converting that to a number. So let's just make a variable here called month start index, set it to none. Month end index, also set it to none. And then we'll use Python's for loop syntax with the enumerate built-in function. Enumerate just iterates through every character of a string or every element of any iterable enumerable item, such as a list, and returns for each item it returns the position. In this case I've called it I, so it'll start with 0, and in this case the character at each string. So kind of have a starting state here, so we'll say, like, if the month start index is still none, which means we haven't yet found that first hyphen, then if the character is a hyphen, then we can now say, all right, well, the month will start at the next position, and so that's going to be I plus 1. Otherwise, if we do have a month start index, that means that we can go ahead and look for the closing hyphen. And if we find it, then we can say the month end index is equal to I minus 1, or I. We'll figure that out. Then, after that loop is finished, we've just found the start and beginning, or the start and end of our month. So now we should be able to pull out the month string by using Python's string indexing. So we'll say month start index, and we want start index to the month end index, and then we'll just convert that to an integer with the int function built into Python. So let's write a little quick unit test here. We'll say take the sample string that we just threw at the beginning of the file here, and this should be equal to the integer 3. So let's just run that. And return string is not defined. Oh, that is not very smart. Month string here. Okay, let's try that again. And it passes. Okay, but we need a little bit of error checking here. What if someone passes in a string like abc-03-def? That is not a date string. We do not want to return 3 for that, because that is not an actual month. So let's do something like this. So if month start index is month end index is none, this means we haven't yet found either of those positions. Every other character in this string must be either a digit or a hyphen. So let's just say if the character is not a digit, then let's just return none. Now, of course, that won't quite work because the first hyphen is actually a digit, so that's not quite right. So let's throw that away here, and let's instead come down here and say, if we haven't yet found the hyphen, and the character is not a digit, then we know we've got an invalid string, so we can return none there. And likewise, here, if this character is not a digit, then we know we've got an invalid string, and we can return none there. So let's test this. Let's just use the test case that we just said here. This should return none. Okay. And let's test that out. And sure enough, that works. Okay. That's pretty good. So that's one imperative approach. It's still not very good, though, because, I could probably come up with other examples of things that aren't right. Like, for example, if I said like this. This is Nate string, but it will actually return 3, I think. Let's take a look. Yep, sure enough, it does. So this is not great. It's more permissive than it should be, and it was also kind of complicated to write. There's a lot of states here to track. Let's see if we can come up with a slightly better way to do this that's still imperative. Let's call it parse month imperative 2. You know what? We're just going to be very specific here. We're going to say, okay, if the length of this date string is not equal to 4 digits plus a hyphen plus 2 digits plus a hyphen plus 2 digits, then return none. So that's basically any string that's not exactly the right length. If the first character is not a digit, return none. And likewise, actually, that's true for the first 4 characters. And then character in the 5th character must be equal to a hyphen. And if it's not, we'll return none. And then we have 2 more digits for the month. And 1 more hyphen. Oops. 2 more digits. And that is a fully validated string there. So we have characters 0, 1, 2, and 3 must be a digit. 4 must be a hyphen. 5 and 6 must be a digit. 7 must be a hyphen. 8 and 9 must be a digit. And now, finally, we can safely say that the date string between positions 5 and 7 will be the month. So let's test that real quick. This is version 2, and 2019 1 should be equal to 3. Let's see that, and sure enough, that passes. And let's just test our other broken case here. Let me pull this up here for you, where we have this weird string here. That should actually be none now, and this. Let's do that original ABC garbage string here. This should also be none with this new implementation. So let's try that out. And yep, all test cases pass once again. So you can see these are 2 imperative approaches. They're not great. Obviously, they're not very good because they're super inflexible, hard to read, and very, very error prone. Lots of lines of code and lots of magic numbers. There is a better way. Let's do a third imperative approach here, where I give it a date string, same signature. But this time, I'm actually going to jump up here and import this utility called date parser. And date parser takes a string and returns a datetime object. And in this case, we can just get the month out, just like that, from the parsed object. So let's take these 3 test cases that we took for version 2 and apply them all to version 3. Let's see if they work. And looks like I do have an error here. It looks like date parser did actually interpret this thing as some kind of date. Let's see what kind of date it actually interpreted it as. It looks like it interpreted it as January 3rd of this year. Okay, well, that's surprising. I did tell it to parse, and it looks like date parser is pretty permissive, but, it's still pretty good. Let's see. Oop. Okay. Oh, so in this case, we actually have to add a little bit of error checking here. So we'll go ahead and do that. Date parser returns none if it can't figure out your date string. Let's try that. And wait for it. Okay, now they all pass. Okay, so those are 3 different imperative approaches. And I think this one might be a little contentious, version 3 here. It's pretty abstract. I'm not telling the computer how to parse the date. I'm just saying parse it and give me the result. So, someone could argue that this is declarative. I personally would not call this declarative. I'm still telling the computer to parse the string. Even though I'm telling it it's a date string, and telling it to use its specialized parsing function for dates, it seems pretty imperative to me. But you know what? If someone said that's declarative, I wouldn't argue too hard. So let's now do a declarative approach. There's still going to be like imperative elements to every declarative program, but this one we're actually going to use Python's regular expression library, which is called RE, and I'm just going to bring that up here. And Python has this RE module, and it has a search function, and the search function lets you pass in a pattern to look for. Using regular expressions, of course, and if you're not familiar with regular expressions, here's a quick crash course. \d is a pattern that says match any digit 0 through 9, and I want 4 of them in a row, followed by a hyphen, followed by 2 digits, followed by a hyphen, followed by 2 more digits, and I want it to apply that pattern on this date string. Now, Python's RE module will return a match object, which will tell you whether or not this matched, and additionally, I can even put little parentheses in here to say I want you to extract specifically this portion of the matched string and store it in this match object as a group. And if that's the case, it will put it inside of group 1 because it's the first parentheses in the match. If I had multiple sets of parentheses, they would be group 2, group 3, etc. So that's the approach there. So this regular expression is very much declarative. I'm saying this is the pattern I'm looking for. Go find it. I don't get to control how it does it. I don't get to say, are you using a for loop? Are you using something, what are you using under the hood? No control over that. Kind of in the same way that the date parser parse function, I have no control over how it works as well. Let's go ahead and test this. Let's use some of our same test cases here. This one is going to be super clear and strict. This will definitely be a date, this first one here. Let me just change the name of that function call. It will definitely match this one. And it will not match this. It won't even think of it as January 3rd. It won't even know that it's a date. It'll simply know there are not 4 digits followed by a hyphen, followed by 2, followed by a hyphen, followed by 2. And same thing with this. So these 3 all should pass. Let's try that out. Okay, they all pass. So this is very, very declarative, in my opinion. Regular expressions are about as declarative as it gets. You're telling the computer, here is the kind of match I'm looking for. You get to declare that, and then the computer does all the work of figuring out how to actually parse the string to apply the pattern that you've matched. So this is what I think a very good example of declarative versus imperative programming. Notice one of the trade-offs you have to make here is I have no control over how the computer goes about parsing that string in this declarative approach. I can't trace it. I can't put debug statements in there. I can't say put a debug right after the third D, \D. It doesn't work that way because this language is a totally different language. And what I think you'll find is that in many declarative situations, you're actually dealing with a different language, and in this case, a regular language, compared to the language that you're working in for your main application. That's true, for example, of HTML. That's true of things like JSON, which are both very much declarative technologies. Whereas, in this parse function, I could actually trace through this code and insert debug statements or breakpoints and figure out what it's doing. Now, to be fair, could I put breakpoints in the regular expression search function? Absolutely, I could. I just can't put them inside of the regular expression itself. Now, presumably there may be some tool on Earth that lets you put in some kind of breakpoint in a regular expression. in the expression itself, not the code that runs the expression, but in the expression itself, I'm not aware of one. So there you go. That's just one simple example. Hopefully that helps contribute to the conversation.